Hi students, in the last few chapters we have studied about acids and bases. In this chapter we're going to study about another type of compound, salts. So what exactly are salts? Are there other salts, apart from the common salt that we use in our kitchen? Also, what are the important, compounds and mixtures that are manufactured from salt? Did you know, for example, that washing soda, a chemical used in detergent soaps, is also made from salt? We'll also learn about bleaching powder, another interesting compound, that's indirectly manufactured from common salt. And we learn about baking soda, yet another important compound that's manufactured from common salt, the salt that we use in our food. So we learn in detail about what a salt is, how salts are named, what common salts are there in the laboratory. We learn a lot of things about salts in this chapter. Let's proceed then. Before we actually start studying about salts, let's rewind what we have already studied in the previous chapters. Some chapters ago, we had understood that all compounds on this earth could be divided into three categories: acids, bases and salts. Now we learnt in detail about acids, right? We've learnt in detail about bases too. Acids were substances which released hydronium ions in water. Bases were substances which released hydroxyl ions in water and neutralized acids. The third category which we haven't yet touched is salts. What exactly is a salt? That's what we learn right away. A salt is a compound which is formed when the hydrogen in an acid is replaced by the metal from a base. Understood? So we know that all acids contain hydrogen, isn't it? Hydrochloric acid is HCl, it has hydrogen. Sulfuric acid has hydrogen because it's H2SO4. So when that hydrogen is replaced by a metal, we get a salt. Let's consider an example. Right here. This is hydrochloric acid. When we replace the H in HCl by sodium or Na, what do we get? We get NaCl, isn't it? And sodium chloride is our common salt that we use in our food, to make our food salty. What you can see here is that the hydrogen in this acid has been replaced by sodium. Simple as that. Similarly, if the hydrogen in this acid is replaced by the metal magnesium, what do we get? We get magnesium chloride, MgCl2. So again, in this case, all that has happened is that the hydrogen in HCl has been replaced by Mg. Understood? So there you go. You've got MgCl2. So whenever the hydrogen in an acid is replaced by metal, you get a salt. Take sulfuric acid here. If you replace the hydrogen here with sodium, you get Na2SO4. Isn't it? Sodium sulphate. Again, we've just replaced the hydrogen with sodium. If you replace this hydrogen of sulfuric acid with magnesium, what do you get? MgSO4, magnesium sulphate. So you can see different salts here being formed when the hydrogen is replaced. So that's about the definition of salts. But how exactly are salts formed? Like, how do you replace this hydrogen from an acid and how do you form a salt? What do you have to do to form a salt? Well, there are actually many techniques, of forming salts. But the most common technique and the technique that we learn in this class is about an acid reacting with a base to form a salt and water. You see, we've learnt in the previous chapters that whenever an acid and a base react, salt and water are formed. So whenever an acid and a base react, the hydrogen of the acid gets replaced by a metal. Understood? So if HCl and NaOH are reacting, then the hydrogen of HCl will actually get replaced by Na. This is because in all neutralization reactions are acid-base reactions, as we learnt earlier. In all acid-base or neutralization reactions, a water molecule is removed from the acid or base, and what remains forms the salt. So if HCl and NaOH are reacting, H from HCl and OH from NaOH will get together to form water, and the metal from the base and the chloride ion or the other ion from the acid will get together to form the salt. This is how the hydrogen in an acid gets replaced by a metal and a salt is formed. Understood? So this is the most common way, in which a salt is formed. An acid and a base react, a water molecule gets eliminated because acids have hydrogen and bases have hydroxyl. So H and OH get eliminated and NaCl forms the salt, or metal from the base and non-metal from the acid, they form the salt. So this is the most common method of salt preparation and you have to remember this. Now, there's one interesting thing related to the formation of a salt. If a salt is formed from acid A and base B, in that case, the acid A is called the parent acid of the salt and the base is called the parent base of the salt. So since sodium chloride is formed when hydrochloric acid and sodium hydroxide react together, hydrochloric acid is the parent acid of sodium chloride and sodium hydroxide is the parent base of sodium chloride. Understood? So the acid from which the salt has been formed, the acid whose hydrogen has been replaced to form the salt, is called the parent acid of the salt. The base whose hydroxyl ion has been replaced, to form the salt, is called the parent base. So the acid and the base which react to form the salt are the parents of this salt. Interesting terminology, isn't it? As if this acid and base are actually parents of this salt. Well, yes, this is the terminology you have to remember. Now that we've understood, what salts are and how they're prepared, let's understand the naming of salt. For example, if we have a salt NaCl, what will we call it? I've just said that NaCl is sodium chloride, but how did I coin the name for this salt? Is there a process for naming this salt? Yes, there is. And it's quite a simple process. If you write, the formula of a salt, say NaCl, then the name of the salt will be the name of the first ion and the name of the second ion. Simple. So the name of this formula, NaCl, will be sodium chloride. This is because the first ion in this salt is sodium, the second ion is chloride. So the name of the salt will be sodium chloride. Simple, isn't it? That's how most salts are named. First ion and second ion. Here's another example. What will be the name of this salt? Well, first ion and second ion. The first ion is calcium. The second ion is chloride. So the name of the salt will be calcium chloride. Take a look at this salt now. ZnCO3. The first ion is zinc and the second ion is carbonate. So the name of the salt will be zinc carbonate. Isn't it extremely simple to name salts? You just identify the ions and first ion and second ion is the name of the salt. Consider this example now. K2SO4. Can you guess the name of this salt? It's potassium sulphate because the first ion is potassium and the second ion is sulphate, isn't it? There is, however, a small exception in this, process of naming salts. The exception is this salt that you see on your screen, CH3COONA. CH3COO is actually called the acetate ion. Acetate, ACETATE, acetate ion. Na is actually the sodium ion. So the name of this salt should have been acetate sodium, isn't it? But no. In the case of this salt, the first ion and the second ion are reversed when you name the salt. This is one of the very few exceptions in the naming of salts. So in this case, the second ion comes first and the first ion comes later. So the name of this salt is sodium acetate instead of acetate sodium. So as you can see, unlike the other cases, in this case we've named the second ion first and the first ion second. But this is one of the only exceptions. In all other cases, you'll have the first ion first and the second ion second. Here are the names of some interesting salts. You might enjoy looking at them. Sodium chloride, NaCl. Calcium chloride, CaCl2. Potassium sulphate, K2SO4. copper sulphate here, CuSO4. Ammonium chloride, NH4Cl. In all these cases, don't get confused at all, because all that's happening is the first ion is being named first, the second ion is being named second. So if you have ammonium chloride, NH4 is the ammonium ion, Cl is the chloride ion, and ammonium chloride is the name of the salt. So as you can see, naming a salt is extremely easy. Now that we've studied, how to name a salt, let's move on to the next concept. The next concept is about determining the parent base and the parent acid of a salt if a salt is given to you. Just a while ago we discussed that a parent acid and a parent base are the acid and base which react to form a salt. So if you are given a salt, say magnesium sulphate, how can you determine what the parent base of the salt is and what the parent acid of the salt is? That's what we're going to study right now. It's quite an easy process. Take a look at sodium chloride, for example. The first part of the salt represents the parent base, and the second part of the salt represents the parent acid. The first part represents the parent base, and the second part represents the parent acid. In case of sodium chloride, what's the parent base? Sodium hydroxide, because the first part represents the parent base, so Na, and then you add OH to it to get NaOH. Cl represents the parent acid, so you add H to it and you get HCl. So this is how you find the parent base and acid. Let's try another example. Zinc sulphate. Again, the first part represents the parent base, so Zn actually represents the parent base. It comes from the parent base, so clearly the parent base must be zinc hydroxide, ZnOH whole twice. The second part represents the parent acid, so clearly the acid that has SO4 in it is H2SO4, sulfuric acid. So you just have to look at the first part of the salt and say which base has this metal in it. You have to look at the second part of the salt and you have to say which acid has this particular ion in it, and there you go, you've got the parent base and the parent acid. Another example, NH4NO3. Again, the first part is NH4. It represents the parent base. So NH4NO3, ammonium nitrate, comes from the parent base ammonium hydroxide, because ammonium ion is part of ammonium hydroxide. NO3 comes from the parent acid. And what's the parent acid? HNO3 or nitric acid, because clearly the nitrate ion is part of nitric acid, isn't it? So determining the parent base and parent acid is actually quite simple. Just look at the first ion and that will represent the parent base. The second ion will represent the parent acid. So that was about identifying the parent base and parent acid, if you know a salt. Now that we've learned this too, let's move on to yet another concept. The family of salts. Salts in general are divided into many groups called families. Salts having the same positive ion or the same negative ion belong to the same family. That's how we group salts into different families. Let me tell you a bit more to make this point clearer. Take a look at these salts here. Sodium chloride, calcium chloride, magnesium chloride, and zinc chloride. All of these salts belong to a certain family. Which family do they belong to? Well, they belong to the chloride family of salts. Understood? The family of chloride salts. This is because the negative ion in all these salts is chloride, isn't it? So if the positive ion in all salts is the same, they belong to a certain family. If the negative ion of all salts is the same, they belong to another certain family. So the chloride family of salts, what all these salts belong to. Take a look at these salts now. Sodium nitrate, calcium nitrate, magnesium nitrate, and zinc nitrate. Which family do all these salts belong to? They all belong to the nitrate family of salts, of course. That's because the negative ion in case of all these salts is the nitrate ion. Understood? So all these salts belong to the family of nitrate salts. So when you're asked to find out the family to which some salts belong, just see which ion is common. If many salts have a positive ion in common, they will all belong to that particular family of salts. If they have a negative ion in common, they'll belong to that particular family of salts. It's quite simple. Again, can you make out which family these salts belong to? Sodium nitrate, sodium citrate, sodium sulphate, and sodium chloride. Again, in this case, the positive ion is common in all these salts, so all of them belong to the family of sodium salts. Understood? So that's how you can identify which family which salt belongs to. There you go. Quite simple. And now that we've studied so much about what a salt is, how a salt is named, how parent bases and parent acids can be derived from salts, and even families of salts, let's solve a problem that will clear our concepts related to whatever we have studied till now. Let's proceed. Write down the formula and the name of the parent acid and parent base for the salts mentioned. 3 of the salts belong to the same family. What is the name of that family? In this question, we are given a table like this. We have to, first find out the name of the parent acid and the parent base in the case of all these salts. Then, the question says that 3 of these salts belong to the same family. We have to find out which family, 3 of these salts belong to. It's not as complicated as it seems. In fact, it's quite simple. Let's begin with the first salt. We have to find its parent base and parent acid. Potassium sulphate is K2SO4. The first part of this, represents the parent base, and the second part of this salt's formula represents the parent acid. So clearly, K, potassium ion, comes from KOH or potassium hydroxide. So potassium hydroxide is the parent base, and sulfuric acid is the parent acid because the SO4 or sulphate ion comes from H2SO4. Sodium nitrate or NaNO3. The first part of the salt comes from the parent base. So the parent base is sodium hydroxide. The second part of the salt comes from the parent acid. The acid containing NO3 or the nitrate ion is nitric acid. So the parent acid is nitric acid. In the case of ammonium carbonate, again, the first part of the salt tells us the name of the parent base. Ammonium ion is present in ammonium hydroxide, so the parent base is ammonium hydroxide. The carbonate ion, the second part of the salt, tells us the name of the parent acid, which is carbonic acid. Magnesium nitrate comes from magnesium hydroxide and nitric acid. First part Mg, MgOH whole twice. Second part NO3, HNO3. Zinc chloride. Zn, the first part, tells us the name of the parent base. Zinc hydroxide, ZnOH whole twice. The second part tells us the name of the acid, hydrochloric acid. Aluminium nitrate. The first part aluminium tells us the name of the base, aluminium hydroxide. The second part, nitrate ion, tells us the name of the parent acid, that's nitric acid. So there you go. It was so easy, calculating the parent base and the parent acid for all these salts. That's how we got our answers. So the first part of the question has been solved, because the first part was to simply find out the name of the parent base and the parent acid. Now we come to the second part of the question. The second part of the question says that 3 of the salts belong to the same family. What's the family? If you observe carefully, we have 3 salts, in the table given. Sodium nitrate, magnesium nitrate and aluminium nitrate. And all of them have the nitrate ion common, isn't it? The negative ion of all these salts is the same. So clearly, these 3 salts belong to the family of nitrate salts. There you go. We have answered the second part of the question also. The three salts which belong to the same family of nitrate salts are sodium nitrate, magnesium nitrate, and aluminium nitrate. Understood? So we've solved this problem. It seemed complicated in the beginning, but then, as you just saw, it was quite simple. Let's now move on to the next concept, the pH of salt solutions.